All right, example 2. Find the capacity to the nearest milliliter of a square pyramid with a base edge of 64 millimeters and a slant height of 40 millimeters. Okay, so there's a lot of information in this question. First of all, it's asking us to find the capacity to the nearest milliliter. Now, to find capacity, we know that we can just find volume first, and then we can find the capacity of a solid with that volume. It's quite easy because we know that 1 milliliter will fit perfectly into 1 cubic centimeter, or 1 cubic centimeter will hold exactly 1 milliliter. So it's quite easy to change to capacity, so we're going to work with volume first. And because it wants us to give the capacity in milliliters, we have an option here of converting these units to centimeters first, so that we end up with a volume in cubic centimeters, which is really helpful if we want to convert to milliliters. Or we can just convert at the end. So we can work it out. We can work out the volume in cubic millimeters and then convert to cubic centimeters later. And we know that to do that, we would just need to divide by 10 cubed because there are 10 millimeters in a centimeter, but we're talking about volume units, so we know it's going to be 10 cubed. So we can do it now if we want, or we can do it later. Let's try doing it now. So we'll convert all of our millimeters to centimeters. We know that 4 millimeters is the same as 40 millimeters is the same as 4 centimeters. 64 millimeters is just going to be 6.4 centimeters. And it's the same over here because it's a square pyramid. So that was pretty easy. Now we know we're going to get our volume in cubic centimeters. Okay, so let's find this volume of this square pyramid. So the formula for volume of a pyramid is V equals 1/3 times the area of the base times the height. And so we're going to need to find the area of our base first. Area of the base, well, our base is just going to be this square base here. All of these lengths are the same, so it's just going to be 6.4, remember we're using the centimeters, 6.4 squared, or 6.4 times 6.4. So 6.4 times 6.4 is 40.96 square centimeters. And that's our value for A now, so we can plug that into our volume equation, or our volume formula. So V equals 1/3 times A, which is now 40.96 square centimeters. May as well write the unit. Times our height. Now our height here, that's our perpendicular height of our pyramid. So from the center of the pyramid up to the top of the pyramid. Now we have a problem here. They haven't actually given us our h value. They haven't told us the perpendicular height of the square pyramid. So we're going to have to work it out somehow. We're going to have to deduce the height of the pyramid. And the way we do this might not be obvious straight away, but don't worry, every single question is going to be like this, so you'll get lots of practice, is they've given us the slant height, okay? We look at what they have given us. They've told us that the slant height here is 40 millimeters. Okay, so we've got the slant height. And what we're trying to find is this height here. Now you can see that we've already started to form a triangle here with these two lines. All we'd need to do is just draw a line along the base here to complete the triangle. And now what I can see is that this base line makes a right angle with the perpendicular height. That's the very definition of the perpendicular height. It has to make a right angle with the base. It has to be perpendicular to the base. So that means that any line we draw along the base here, that must be perpendicular to our height, our perpendicular height. So now I can see, it's music to my ears, a right angled triangle. So you can see that we've got this right angled triangle, and you kind of need to visualize it because it's on a bit of an angle. This is not to scale. This is the height. This is our slant height of 40 millimeters. Oh, sorry, we're going to use centimeters, of course. 4 centimeters. And then we've got our base of our triangle, our other side. We haven't actually labelled it, but we can work out what it is pretty easily because we know that it starts at the edge of the square base here and then finishes in the very centre of the square base. So it has to be half of the length of the square, right? If this length here is 64 millimetres or 6.4 centimetres, then this length here has to be 64 millimetres or 6.4 centimetres as well. And we just need half of it to make up the base of the triangle there. So half of 6.4 centimetres is 3.2 centimetres. So we've got a right angle triangle here and we've got 2 sides in the right angle triangle, which means we can work out that other side using Pythagoras' theorem. So Pythagoras' theorem is c squared equals a squared plus b squared, where c is the hypotenuse. All right, so our hypotenuse is 4 centimetres, so it's 4 squared equals, and a and b are just the other 2 sides, doesn't matter which one's which, so let's just say h squared plus 3.2 squared. And now if we rearrange this equation and solve for h, we'll finally end up with our perpendicular height, which is what we need to work out the volume of this pyramid. All right, so this is quite a long question. So 4 squared over here is 16 equals h squared plus 3.2 squared is 10.24. We want to isolate h, so we need to get rid of this here. So let's subtract 10.24 from both sides. And we end up with 5.76 on the left-hand side and h squared on the right-hand side because these just cancel out. And we need to isolate h. We're nearly there. We just want to get rid of this power of 2 that it's got. So we just need to take the square root of both sides. And usually we take the positive and negative square root. But because we're talking about length, we only really need to worry about the positive square root. So let's just take the positive square root both sides here, and we end up with the square root of 5.76, which is 2.4, and the square root of h squared is just h. So finally, we have our perpendicular height, which is 2.4 centimetres. Okay, so we can plug that back into our formula here, 2.4 centimetres. And finally, we have enough information now to work out the volume of the pyramid. So I'm just going to write it down here. And we just need to plug this expression into our calculator. 1/3 times 40.96 times 2.4 gives us 32.768 cubic centimetres. And we're nearly finished the question now, but remember, if we go back up, the question asks us to find the capacity, okay, not the volume. So now that we've got the volume, we just need to convert it to capacity, and it's just to the nearest milliliter. So we can just convert straight to milliliters now because we've got it already in cubic centimetres. So the capacity, we know that 1 cubic centimetre holds exactly 1 milliliter. So the capacity is just going to be 32.768 milliliters. And we're done. We've now got the capacity in milliliters. Oh, but it says to the nearest milliliter, sorry. So we don't need all these decimals. We can just say that it's 33 milliliters to the nearest milliliter. So quite a long question. We had to use Pythagoras. We had to use our knowledge of conversions between volume and capacity. And we had to use our formula here for the volume of a pyramid, which also meant that we had to use our formula for volume of a square here as well. So lots of parts to this question, probably worth about 4 marks, maybe more.